Welcome to this lesson on the Series 65 exam. Today's lesson is going to be on analytical methods, which is a crucial section of the Series 65 exam that accounts for approximately 15% of your test score. So yeah, it's definitely worth it to pay attention to these topics. This section is focused on equipping you with quantitative tools needed to evaluate investments, compare portfolio performance, and understand risk-adjusted returns. You don't need to be a mathematician, but you do need to understand the concepts and be able to interpret the results. So we're going to cover two major areas today. The first is time value of money concepts, including the internal rate of return, or IRR, the net present value, or NPV, and the future value, FV. The second field that we're going to cover are descriptive statistics, including measures of central tendency, the mean, median, and mode, measures of dispersion, range, and standard deviation, and investment-specific metrics such as alpha, beta, Sharpe ratio, and correlation. All right, so let's go ahead and get started with the time value of money and the related concepts there. So the time value of money, sometimes it's just abbreviated the TVM, is the principle that a dollar today is worth more than a dollar in the future because it can be invested to earn a return. So if you think about it that way, that helps you see things in a little bit of a different light. You're thinking like an investor. So, first concept related to this is the internal rate of return, or IRR. IRR is the discount rate that makes the net present value, or NPV, of all future cash flows from an investment equal to zero. So if that's a little confusing, let's put this in a little bit simpler terms. It's the break-even rate of return on an investment. If the IRR is greater than the required rate of return, then you should accept the investment. That's a good investment. However, if the IRR is less than the required rate of return, then you should reject that investment. That's not a good investment for you to take. There are a few assumptions that we make when we're talking about IRR. One is that it assumes that all interim cash flows are reinvested at the IRR. That may or may not be true, but that's what it assumes. And then it's often used to compare projects or evaluate private equity, real estate, or venture capital. On the exam, you need to know how to interpret IRR results. You won't be asked to calculate it by hand, but you should be able to look at that and say, hey, is this a good investment or a bad investment based on the IRR? The next topic is the net present value. So the NPV, net present value, is the sum of present values of future cash flows minus the initial investment cost. So once again, the NPV is equal to present value of inflows minus the initial investment. So if the NPV is greater than zero, then your investment is adding value. And on the other hand, if NPV is less than zero, then your investment is losing you value. So that's another good metric to look at. So why does NPV matter? It considers both the timing and the magnitude of cash flows. Unlike IRR, NPV does not assume reinvestment at a specific rate. So on the test, you must understand how NPV and IRR relate and which provides a better decision metric under different assumptions. So they're assuming different things. They might be better at giving a good diagnosis in different situations. Next, we have what's called the future value, or FV. Future value answers the question, what will an investment made today be worth in the future? So once again, there is a formula attached to this. So the FV, future value, is equal to PV times 1 plus R to the nth power. Well, that doesn't make a lot of sense by itself. So let me break down these variables. So PV is the present value, R is the rate of return, and N is the number of periods. So once again, FE, the future value, is equal to the present value plus a time, is equal to the present value times 1 plus the rate of return, all of that together, to the nth power, the number of periods. So for example, let's actually plug some numbers in there to make that a little clearer. So if you invest $10,000 at 5% return for 3 years, so the future value is equal to $10,000 times 1 plus R, so that's 1.05 to the third power. That's the number of periods, 3 years. That is equal to $11,576.25. So after you've invested, you can look at that and say, okay, after 3 years, I will have gained about $1,500. So why this matters? Future value helps clients understand compound growth. It is used in retirement planning, savings goals, and comparing investment alternatives as well. All right, so let's shift gears a little bit and talk about descriptive statistics. So these are some mathematical concepts as well that are pretty widely applicable. So it's a good thing to understand these because they will be applicable in a variety of situations. So descriptive statistics help analyze historical returns, they help assess volatility, and they can help you evaluate how a portfolio behaves in different environments. So, like I said, very helpful tools. So first, when we're talking about statistics, ground concepts are the mean, the median, and the mode. So what do all of these three things mean? What does mean mean? The mean is simply another word for the average. It adds all of the values together, and then you divide it by the number of values. The median is the middle value when the data is arranged in order. So you set it up from least to greatest, and then you take the value that's right in the middle. That is the median. It's kind of like in the street, there's that center part that divides the traffic from going one way into the other way. That's also known as the median. It goes in the middle. We also have the mode, and the mode is the value that appears most often. So if you have a string of numbers and you line them all up, you put all the same numbers together, you see how many times does each value appear, and the value that appears the most is the mode. So for example, let's say the data that you have is 3%, 5%, 5%, 6%, and 7%. So the mean, we would take all of those values, we'd add them up, 3 plus 5 plus 5 plus 6 plus 7, and then we divide them by the number of values. So divided by 5, because I have 5 values, and that will give you 5.2%. So the mean of all of those values is 5.2%. However, that's not the same as the median. So if we line those up in order, 3, 5, 5, 6, 7, the number that's right smack dab in the middle is 5. So that means the median is equal to 5. And then, in this case, what is the mode? So we have 3, 5, 5, 6, 7. What number appears the greatest number of times? That would also be 5. In this case, the mode is also equal to 5%. So why does this all matter? Knowing about means, medians, and modes. These values help you summarize return data. The mean is most often used. That's what you're going to use, that average most often. But the median is better when the data is skewed. So there's some factor that is skewing the data so that the mean might not be as accurate as you would like. You can also then take the median instead. All right, another concept that we should talk about is range and standard deviation. So the range is the difference between the highest and the lowest values, measure spread. The standard deviation, however, measures how much returns deviate from the mean, so the average. A higher standard deviation equals higher volatility. So for example, if a fund has an average return of 8% with a standard deviation of 2%, most returns will fall between 6 and 10%. So you see what I did there? The standard deviation is 2, so I went 2 below 8% down to 6, and 2 above 8% to 10. So the standard deviation is 2 in both directions. So most of the values, the standard deviation from the average of 8 is 2%. So the vast majority of values will fall between 6 and 10%. Why does this matter? Standard deviation is a core risk metric. A higher standard deviation may indicate a riskier investment because you're getting a broader number of possible values. So it's volatile. It's not something that you can depend on. It could be up here, it could be down there. If it's all over the place, a greater standard deviation should make you raise an eyebrow. But if the standard deviation is nice and small, then that can also show, hey, this is something that's more stable. We're getting more values that fall into this small sleeve of values. All right, the next term I want to talk about is alpha. So alpha measures a portfolio's excess return above its expected return based on its beta, risk level. We'll talk about beta here in just a minute. So positive alpha means that something has outperformed expectations. And negative alpha means the opposite, that it has not met expectations. So this is the formula for calculating alpha simplified. So alpha is equal to the actual return minus the expected return that's based on beta. So why does this matter? Alpha shows if an advisor added value through skillful management. So you can say, hey, we expected this, but look, our return was this much better. And so that reflects well on the advisor. All right, so beta, what does that mean? Beta measures a security's volatility compared to the market. So the market beta is, we set that at 1. So that's kind of like the default setting. If a beta is greater than 1, it's more volatile than the market. A lot of tech stocks are this way, where they're more volatile. They're either get rich quick or go home broke quickly. They've got a lot of volatility, and they can either make or break you. A beta of less than 1 is less volatile than the rest of the market. A lot of utility stocks, there's not a lot of risk on those. They're not very volatile typically, so they'll typically have a smaller beta value that is less than 1. But if you have a beta that's close to or exactly 1, that means that it's moving in line with the rest of the market. So here's a use case. Beta helps assess systematic risk. That's market risk. It's used in asset allocation and risk tolerance assessment. So you talk to your client and they're like, I can't tolerate a lot of risk. I don't want things that are too volatile, too risky. And so you would then make a beta assessment and say, hey, look, is this investment riskier than the market? Is it more volatile than the rest of the market? Does it have a high beta greater than 1? And you say, oh, I don't want to do that. So I want to find things that are less volatile. You might say, let's do some utility stocks instead. The next term we should talk about is the Sharpe ratio. Sharpe ratio measures risk-adjusted return. How much excess return you receive for the extra volatility. So these volatile stocks can be, as I mentioned, high risk and high reward. So the question is then here in the Sharpe ratio, how much extra reward could you possibly get for assuming this higher level of risk? So here's the formula. The Sharpe is equal to the return minus the risk-free rate divided by the standard deviation. And this means that higher Sharpe, the higher the ratio is better risk-adjusted performance. On the exam, you need to know that the Sharpe ratio compares total risk, unlike alpha and beta, which focus on market-related risk. So total risk takes all these different factors into account, where alpha and beta are just looking at strictly market risk. Okay, and the final term I want to talk about is called correlation. Correlation measures how two securities move in relation to each other. If you have a correlation of 1, that means you are perfectly positive correlation. They move completely with each other all the time. If you have one of 0, that means there is no correlation. When one moves, it doesn't affect the other one. And if you have a correlation of -1, that's perfectly negative correlation. So when one goes up, that causes the other one to go down by the same amount. And a lot of things fall somewhere along that spectrum between -1 and 1 when talking about correlation. One way you can look at this is that there's a benefit in diversification. So if you combine assets with low or negative correlation, this reduces your overall portfolio volatility. Because if there's negative correlation, if one goes down, the other one goes up. And so that helps offset the one that's going down. That makes sense. So if you diversify and you're looking for things with negative correlation, that can help you experience less volatility overall in the portfolio. All right, there are a lot of different terms in this lesson. Let's recap the lesson real quick, and then we'll move on to the assessment portion of this lesson. So let's summarize the key concepts. IRR and NPV help determine whether an investment is worthwhile, whether you want to take it on. You're going to make money over time. Future value helps project returns over time using compounding, the power of compounding interest. So you might want to look at that formula. That was probably the most complicated formula that we talked about. Descriptive statistics, such as the mean, median, mode, range, and standard deviation, summarize return data and assess volatility. So especially that standard deviation. You want to look for things that have maybe a lower standard deviation so that you can see they're not quite as volatile. The alpha, beta, and Sharpe ratio evaluate performance and risk. And then correlation helps in constructing diversified, efficient portfolios. Mastering all of these tools will boost your performance on the Series 65 exam, and of course your effectiveness as an advisor when you actually go into the field. All right, so now we have some multiple choice questions and a few short answer questions to see if you remember what we talked about. If you do well on this, you're ready to move on to the next lesson. My first question, which analytical tool shows the discount rate that sets an investment's NPV to 0? Is it the A, net present value, B, internal rate of return, C, Sharpe ratio, or B, alpha? This is the IRR, or internal rate of return. Next, a project has a positive NPV. What does this indicate? A, the IRR is negative. B, the investment should be rejected. C, the project will lose money. Or D, the investment is expected to add value. The correct answer is D, the investment is expected to add value. Which formula is used to calculate future value, or FV? Is it FV equals PV times 1 plus R to the N? B, FV equals PV divided by 1 plus R to the N? C, FV equals alpha times beta? Or D, FV equals cash flow minus expenses? In this case, it is A, FV equals PV multiplied by 1 plus R to the N. So you're going to go back in the lesson and review what those terms mean, what each of those variables mean, if you don't remember that. All right, next, Which measure indicates how far returns deviate from the average return? Is it A, alpha, B, Sharpe ratio, C, standard deviation, or D, beta? In this case, it's C, standard deviation, how much they deviate from the average. All right, 5. What does a beta of 1.2 indicate? A, the security is 20% less volatile than the market. B, the security moves independently of the market. C, the security is 20% more volatile than the market. Or D, the security has no systematic risk. The answer is C, the security is 20% more volatile than the market. So it's greater than 1 by 20%. So that's how you know that. Next, a portfolio has a Sharpe ratio of 1.8. What does that suggest? A, it is underperforming. B, it has no correlation with the market. C, it has good risk-adjusted returns. Or D, it's losing money. The correct answer is C, it has good risk-adjusted returns. Next, what is the median of the following returns? 3, 4, 6, 6, 9. Once again, the median of 3, 4, 6, 6, 9. Is it A, 5, B, 6, C, 4, or D, 9? In this case, the median, that middle point, is 6. So 3, 4, 6, 6, 9. The number right in the middle is 6. Which term best describes the tendency of two assets to move in opposite directions? Is it A, positive correlation, B, neutral correlation, C, negative correlation, or D, beta divergence? The answer is C, negative correlation. So they have a tendency when one asset goes down, the other one goes up, and vice versa. There's a negative correlation. So that's an important concept when we're talking about diversification. So you often want assets that have a negative correlation into each other to help offset each other. All right, the next is alpha measures which of the following? A, volatility compared to the market. B, the risk-free rate of return. C, excess return above risk-adjusted expectations. Or D, the total return on a bond. The correct answer is C, the excess return above risk-adjusted expectations. And this can be used to help an advisor look good if they've got a lot of extra return above expectations. And then finally, if an investment returns equal the market return and has a beta of 1, what is the alpha? A, positive, B, negative, C, 0, or D, unknown? In this case, it's C. There is no alpha. If it's just at the beta of 1, there's no excess, there's nothing over, that means there's no alpha. All right, to wrap it all up, we're going to give you 3 open-ended questions. And I'll give you a sample response, though your response does not have to exactly match my response. The first question is, how can investment with a high return still be a poor choice? So this is one that has perhaps a few different answers you could give, but one sample. If the investment has high volatility or risk, its Sharpe ratio might be low. Risk-adjusted return is more important than absolute return for portfolio construction. All right. Number 2, what does a negative correlation between two assets suggest about diversification? So a negative correlation means that when one asset goes up, the other tends to go down. This reduces overall portfolio volatility and enhances diversification benefits. And finally, 3, why might IRR be misleading when comparing multiple projects? Think about that for a sec. So for example, IRR assumes reinvestment of interim cash flows at the IRR itself, which may not be realistic. When projects differ in size or timing of cash flows, NPV is often the better decision tool. All right, how did you do? If you're feeling great about it, it's time to move on to the next lesson. If not, please review before continuing. Our next lesson will be understanding types of risk and capital structure. And that's all for our lesson for today. Thank you very much for listening.